Hey guys, welcome again to the Maths Club. If you're just joining us, you're welcome. So for some time we've been looking at number base. We looked at introduction to number base. How do we operate in them? How do we do some basic operations like addition, subtraction, division? How do we convert from one base to another? Right. So if you are just joining us and you've not seen any of those videos, you can click on the playlist that will appear at the top right, just to be intimate to some of those videos that we've done before. But in this particular video, we're going to be treating past questions, right? Based on all the things we have learned before, we're going to be solving WAEC questions from 2004 up to 2023 that covers number base, right? So without further ado, let's get started. Remember, according to WAEC, there are some objectives that they want you to know. These are very, very good to know, right? Great. So the first question is saying, or it's taken from June 2004, right? It's saying evaluate 202 squared in base 3 minus 102 squared in base 3, right? You know, they have the same base, so that makes it even easier for us. Let's look at the options. Great. So let's solve. So we have 202 squared in base 3 minus what? 112 squared in base 3. Let's take this first one. So if I were to multiply 202 like we have been doing, right? I will multiply it twice. 2 times 2 is 4. Remember, this is in base 3 and this is also in base 3. So like we did before, 2 times 2 is 4. We divide that 4 by the base we're operating with, Abi, and that will be 1 with the remainder of what? 1. As always, we drop the remainder, which is 1, and we carry over the results, which is 1 in this case. 2 times 0 is 0 plus 1, that is 1. 2 times 2 is 4, right? 4. We always do this division whenever we meet a value that is equal to the base or greater than the base. Now we've met the value 4. 4 is greater than the base, so that will be 4 divided by 3, right? Which is still what we still have at the top here, and that is 1 remainder 1. So I'll drop 1 here and I'll carry over 1, right? And as we always say, just imagine that there is a 0 here, right? You now say maybe 2 times 0, which will give you 0 plus 1, which will give you 1, right? It's just an imagination, right? So this 0 to multiply each of these things here, so that will be 0, 0, and 0, right? Next, we move to the next one. So 2 times 2 is still 4. We have 1 remainder 1. As always, I'll drop the 1 and carry over the other one, right? 2 times 0 is 0 plus 1, which is 1. 2 times 2 is 4, right? Like always, we write 1 and we carry over 1. So imagine there's a 0 here. So that will be 2 times 0 will be 0 plus 1, which is what? 1. Great. Remember, we are working in base 3, right? So by the time I add all of this together, if I reach a value that is equal to 3 or greater than 3, I'll have to do this division, then 1 remainder 1 or anything like that. So let's see, let's add. So this is 1. This is 1 plus 0 is 1. 1 plus 0 plus 1 is 1. Sorry, 1 plus 0 plus 1 is 2. 1 plus 0 plus 1 is 2. This is 1 and this is 1. We didn't encounter a number that is equal to 3 or greater than 3, so that's good. So this is the solution for the first part of the square. Now let's move to the second part of the square, which is 112 squared. So 112 multiplied by 112, right? Remember, we're working in base 3, so let's put it there. 2 times 2 is 4. Still the same thing, right? So we'll have 1, carry over 1. 2 plus 2 is 2 times 2 is 2 plus 1, that is what? 3. 3 is the same base we're operating in, so we can't write 3. We have to do that division, so that will be 3 divided by 3. In this case, we have 1 with the remainder of what? What will be the remainder? Great, remainder of 0, right? So I drop the remainder, I carry over the value. 2 times 1, that's 2, plus 1, that's 3. Same thing here, 3 divided by 3, so I will drop 0, I'll carry over 1, right? But there's nothing to multiply, right? So that's why we always assume an imaginary 0. 2 times 0, 0 plus 1, that is what? 1, right? Right. So let's see. 1 will multiply all of this, so that will give me 2, 1, 1. 1 times 2, 1 times 1, 1 times 1. 1 to also multiply all of this, that also give me what? 2, 1, 1. Abi? Now let's add. This will come down. 0 plus 2 is 2. 0 plus 1 is 1, plus 2, that's 3. If we've met the base that we're operating in, right, which is base 3, so we have to do this division. 3 divided by 3, that is 1 with the remainder of 0. So I'll drop the 0 and carry over the 1. 1 plus 1 is 2, plus 1, 3, plus 1 is 4. 4 divided by 3 is 1 with the remainder of 1. So I'll write this one here and carry over the results. In this case, which is what? 1. 1 plus 1 is 2, right? So the answer to this is actually 21021 in base 3. That is the answer to this particular one, right? So we found the square of this. If any of this is actually looking strange, right, you might want to really check that playlist that we've been doing, because we're building on the fact that we've treated this before, right? Now we have the square of this. We've not found our answer, because our answer is saying that we should subtract the square of this from this. So let's subtract this value from this value, right? So if I go from left to right, that will be 1 in base 3, 2, 0, 1, 2, right? Subtraction. Great. 1 minus 1 is 0, right? In base 3. 1 minus 2, because 1 minus 2 cannot do, we have to borrow from this, so this will become 1. Remember, when we were doing the subtraction, when we borrow from 1, what do we add there? We add the base we are operating in, so that will be base what? That value here will be 3. Unlike when you're operating in base 10, where you add 10 to this value. But now that we're operating in base 3, we're adding 3 to this value. So when we borrow 1 from this, we get 3. So 3 plus 1 is 4. 4 minus 2 is 2, right? 1 minus 0 is 1. 2 minus 1 is 1, right? 1 minus 2 cannot go, so I have to borrow. So I'll borrow from this guy, right? And because I'm operating base 3, I'll add 3 to this guy. 3 plus 1 is 4. 4 minus 2 is 2, right? So that means by the time we find the square of both of them, right, and we subtract, we're going to have what? 21120 in base 3. Let's see if our answer is there. 21120 in base 3. That is option A. Great, and that means we got it right. I actually like this question because it sums up a lot of things that we've been doing all this while. Squaring, and subtracting. Let's move on. So number 2 says, if y is equal to 23 base 5 plus 101 base 3, find y, leaving your answer in base 2. Right? So if y is equal to 23 in base 5 plus 101 in base 3. If you've been following us, I will advise that you actually pause the video and try it out yourself. Welcome back. Alright, so because they are in different bases, as I said, anytime you're adding different bases, you have to convert each of them to base 10. So let's convert this one to base 10. Right, so that will be 2 times 5, right, plus what? 3 times 5. After we do that, from the videos we've been doing, we said we give them powers from right to left, starting from 0. So this is 0 and this is 1, right? Plus, let's convert this guy to base 10. That will be 1 times 3 plus 0 times 3. Let me move it to this side so that we can have a bit of more room to operate in. 0 times 3 plus 1 times 3, right? 1 times 3, 0 times 3 plus 1 times 3. So we'll give it a power of 0 from right to left. So this will be 0, this will be 1, and this will be 2. Right, so we've converted this to base 10. But let's simplify. 2 times 5 raised to the power 1. 5 raised to the power 1 is 5, right? Plus 3 times, anything raised to the power 0 is 1. So that will be plus 3 times 1, right? So we've actually treated this bracket. Plus this bracket here. 1 times 3 squared is 9. So I'll put 9. Plus 0 times, like I said, anytime you have 0 multiplying, you don't need to bother yourself. Just say plus 0. Plus 1 times 3 raised to the power 0. Anything raised to the power 0 is 1, right? Great. So let's simplify now. We can simplify. 2 times 5 is 10. plus 3 times 1 is 3, plus in brackets 1 times 9 is 9, plus this is 0, does not change anything. 1 times 1 is 1, right? So we can now add. Let's add. So that will be 10 plus 1 is 13, plus 9 plus 1, that's 10. So we got 23, right, in base. So we got 23 in base 10, right? But did our answer say we should leave it in base 10? No, we said leaving your answer in base what? In base 2. So we have to convert to base 2, right? So from the videos that we did about converting, we do a long division. So 23, we divide it by 2. 2 in 2 is 1. 2 in 3 is 1, right? But there will be a remainder of 1, yeah? 2 in 11 is 5, and there will be a remainder of what? 1. 2 in 5 is 2. There will be a remainder of 1. 2 in 2 is 1. There will be a remainder of 0, right? We don't stop until we get 0 here. So 2 in 1 is going to be 0, with a remainder of, just bring whatever you have here down, right? And like I said, we're going to start from the bottom to the top, right? So that will be 1 0 1 1 1 in base 2. So this is our answer. 1 0 1 1 1 in base 2, and that's option what? Option B. Great. We are actually doing very great, right? So you can see our answer is actually correct. Now let's solve the next question. So this is taken from 2005 in June. So it says we should convert 1 0 1 1 0 1 in base 2 to a number in base 10. Right, so let's go. 1 0 1 1 0 1 in base 2 to a base 10, right? And let me just say to a base 10. So I encourage you that you pause the video, you try to solve. Welcome back, right? So let's see, how do we do that? So converting to base 10, we'll just multiply each of the values by the base. So 1 times 2 plus 0 times 2 plus 1 times 2 plus 1 times 2 plus 0 times 1 plus 1 times, let me shift to this side, 1 times 2, right? So from right to left, we start from 0. Okay, so I add 1 times 2, 0 times 2, 1 times 2, 1 times 2, 0 times 2, so this should be 0 times 2, not 1, right? Plus 1 times 2, so this is 1, this is 2, this is 3, this is 4, this is 5, right? Great. So let's simplify. 1 times 2 raised to the power 5, right? If you check your calculator, that will give you 32, right? Plus 0 times, so whenever I see 0, I don't need to bother my head, so I'll just put 0 plus 1 times 2 raised to the power 3 is 8, right? Plus 1 times 2 raised to the power 2 is 4, right? Plus 0 times, I don't need to bother my head, I'll just put 0 plus 1 times 2 raised to the power 0, and 2 raised to the power 0 results is 1, right? So 1 times 32, that's 32, plus 1 times 8, that is 8, plus 1 times 4, that is 4, plus 1 times 1, that is 1, right? So 32 plus 8, that is 40. 40 plus 4, that is 44. 44 plus 1, that is 45. So this value in base 10 is actually 45 in base 10. Let's see if our answer is there, right? So that's option what? Option C, right? Great. We did very well. Now let's move to the next question. This next question is saying, it's taken from June 2006, right? And it's saying subtract, right? We're having the same base, so we don't need to convert to base 10 really. We can subtract it like we did when we're treating subtraction. So we have 1 1 0 1 1 1 1 0 1 1 minus what? 1 1 0 1. We're dealing in base 2. 1 1 0 1 1 minus 1 1 0 1. Great. So 1 minus 1 is 0. 1 minus 0 is 1, right? Which is less than the base. Now 0 minus 1 cannot happen, so I have to borrow from this. This is down to 0, right? Like I said, what will I carry over? I'm not carrying over 1. I'm carrying over the base that I'm actually operating in, and that's what 2, right? So 2 minus 1, this will give me 1, This is 0. 0 minus 1 cannot, so I have to borrow from this guy, 0. Right, then I'll carry over what? The base, which is 2. Right, so 2 minus 1 is 1. Right, so this is our answer. 1110 in base 2. Let's see. 1110 in base 2. That's option C. Great. See how very simple it is, right? So all we did, if you are finding any of this strange, just go to the playlist on number base. You'll see where we're talking about subtraction, right? And it's all there for you to knock yourself out with. Let's go to the next question. This next question is saying that we should evaluate 111 base 2 squared and leave your answer in base 2, right? So that's just saying 111 times 111, and it's taken from June 2007, right? So let's solve. 111 in base 2 multiplied by 111 in base 2, right? So 1 times 1 times 1, so this is 1 times 1 is 1, 1 times 1 is 1, 1 times 1 is 1, right? 1 times 1 is 1, 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 1 times 1 is 1. So this is 1. I remember working in base 2, right? 1 plus 1 is 2. We've already made a number that matches the base, so we have to do our division. So 2 divided by 2. 2 divided by 2 is 1 with a remainder of what? Of 0. So I'll drop the remainder and carry over the result, which is 1. 1 plus 1 is 2. 2 plus 1 is 3. 3 plus 1 is 4, right? 4 is greater than the base, so I'll do this division. So 4 divided by 2, right? My answer is 2, remainder 0, right? So I'll drop the remainder, which is 0, and carry over the 2. 2 plus 1 is 3. 3 plus 1 is 4. Still the same results here. So I'll drop the remainder and carry over the surplus. 2 plus 1 is 3. 3 is greater than 2. So I'll do 3 divided by 2, right? Which is 1, remainder what? Remainder 1, right? So I'll drop 1 and carry over 1, right? Remember, just like we always say, since there's nothing to add it, we assume that there's an imaginary 0 here, right? So that will be 1 plus 0 is 1. So when we square 111, we have 110001. Let's see if our answer is correct. 110001, which is option B. 110001, option B. Great, 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 great. Let's continue. So it says convert 42 base 5 to a base 3 numeral. I want you to pause this video and actually try it out by yourself. Welcome back. So what do we say when we have a base? We have a base and we're converting to another base. We first convert to our fundamental base, which is what? Base what? Base 10. Great. And then the base 10, we'll now convert that base 10 to base 3. So let's do that. So 42 in base 5. Let's convert it to base 10. So that will be 4 times 5 plus 2 times 5, right? I'm going to give the power from 0 starting from left to right. So this is 0 and this is 1. So 4 times 5 is actually 20, Abby? Plus 2 times 5 reciprocal. 5 reciprocal is 1, so 2 times 1 is 2, right? So we have 22, right, in base 10. But instead we should convert the value to what? To base 3. So we have to do our long division method, right? So 22, divide this by 3. 3 in 22, that will give you 7, right? With a remainder of what? Of 1, great. So 3 in 7 will give you 2, right? With a remainder of what? 1, because 3 times 2 is 6. 7 minus 6 is 1. 3 in 2. 2 divided by 3. That will give you 0 point something, right? So that will give you 0. We're not just in the whole number part. And the remainder, you just bring whatever value is there, you bring it down. So from bottom to top, that means our answer in base 3 is 211 in base 3. 211 in base 3. That's option what? C. Great. Great. So let's continue to the next question. So the question says, if all numbers in the equation are in base 2, solve for y. Right, so let's pen down the equation. So this is y over y plus 101 is equal to 11 over 110. Right, remember all of these are in base 2. I should solve for y. So let's cross multiply. That will be y times 110 is equal to 11 times y plus 101, right? Let's expand the brackets. This would be 11y plus 11 times 101. Remember, this is in base 2. And this would be 10y. So if I do 101 times 11, remember, we're working in base 2, right? 1 times 1 is 1, 1 times 0 is 0, 1 times 1 is 1. 1 times 1 is 1, 1 times 0 is 0, 1 times 1 is 1, right? Let's add in base 2. So this would be 1, this would be 1, this would be 1, and this would be 1, right? Great. So this would be 10y is equal to 11y plus 1111. So if you look at it, the next thing that we're meant to do is to correct like terms. This is y, this is y. So let's carry this one to the other side. If I carry a plus to the other side, it's going to be minus, right? Great. So that would be minus 11y is equal to 1111, right? So let's subtract this. Or before we do that, let's factor out y. We can factor out this one as y, this one as y. We can factor out y from this, right? So that would be 10. This divided by this will be 10010 minus this divided by this minus 11, right? Is equal to 1111. Let me put base 2 here so that we don't forget that we're actually working in base 2. So let's subtract these two guys. That will be 100 minus 11, right? Base 2 and base 2. I'll borrow 0 minus 1 is not going to work, so I have to borrow 1 from this. This will make this one to be 0. So I'll be carrying over what? Great, so got it. I'll be carrying over 2. Yeah, so 2 minus 1 is actually 1. Right? 0 minus 1 cannot go, so I have to borrow. No, I have to borrow from this guy. So this is 0. I'll carry over 2. This will turn 1. I'll carry over 2. This will turn 1. Now carry over 2. So 2 minus 1 is 1. Then this guy is 1. Then this guy is 1. Right? So when I subtracted this guy, I had 1111y, right, in base 2 is equal to 1111 in base 2. Can you see? So I have the same thing. So this is like saying 1111 times y is equal to 1111. So what can I do basically? What do you think I can do? So if I have, for example, if I have 5x is equal to 25, right? And I want to find x, I can divide both sides by 5, abi? So 5 will cancel 5, 5 here 1, 5 here 5, so x is 5. So it's the same thing I'm going to do here. I will divide both sides by, so I will divide both by 1111, right? So if I divide both sides by 1111 divided by 1111 in base 2 is equal to 1111 in base 2 over 1111 in base 2, right? So if I cancel out, this guy will cancel out this guy, this guy will cancel out this guy, right? This guy canceling out this guy will give me 1, right? So same thing, by the time I now move this one up, that means my y actually was what? My y was actually 1, right? So what did we do? Let's recap. We cross multiplied first off, then we expanded the brackets. Yeah, we multiplied, we expanded the brackets here, this guy times this guy, this guy times this guy, and that's what we did here, right? Then after we did that, we created like terms. We brought these guys to this side so that y can both be on the same side, right? So after that, we now factored out the y. When we factor out the y, we add this, right? And then we subtracted this guy. Then he gave us 1111y is equal to 1111. Since they have the same this thing, we just divided both sides by the 1111. So we found our y to be equal to what? To be equal to 1, right? I actually like this question because it's very, very inclusive of different things that we've done. So let's see. So our y is equal to 1. So you can find this question in 2008. It came in the theory part. let's go to the next question. So this question says, arrange the following numbers in descending order. So when they say descending, that means from the highest to the lowest, Abi. So you're going from the high guy and you're descending down, right? So we have 22 base 3. 22 base 3. We have 34 base 5. And we have 21 base 6. I want to arrange this guy. You can see they're in different bases, so we might not be able to actually know what to do at first phase. But because they're in different bases, if I convert them to base 10, you agree with me that I'll be able to find a true reflection of what value each of them actually holds, right? So you might want to pause the video and convert each of them to base 10. Welcome back, right? So let's convert this guy to base 10. So that will be 2 times 3 plus 2 times 3, right? So this give the power from right to left, 0 and 1. 2 times 3 is 6 plus 2 times 3 raised to power 0 is 1. So 1 times 2 is 2. So this guy is actually 8, right? 8 in base 10. This guy here is what? 3 times 5 plus 4 times 5, right? And give it 0 and 1. 3 times 5 is 15 plus 4 times this is 1, that is 4. So this guy is 19, right, in base 10. This guy will be 2 times 6 plus 1 times 6, power of 0, power of 1, right? 2 times 6 is actually 12 plus 1 times 6 plus 0 is 1. So that will give me 13, right? So I have 8 and I have 19 and I have 13. Okay, so I mean we can see from first view that this is the highest. So this will be position 1, followed by this guy position 2, then followed by this guy position 3. So what is the order that our answer is going to be? So that will be 34 base 5. Let me move this here. Base 5 to 21 base 6 to 22 base 3. Base 3. So let's see. 34 base 5, 21 base 6, 22 base 3. That is option D. Great, option D. So our answer is correct. So the next question is saying convert 35 base 10 to a number in base, right? So 35 to a number in base 2. So I'll also say 35, right? I'm dividing it by 2 the first time. 35 divided by 2, right? That is 17, right? But there will be a remainder of 1. 17 divided by 2, that is 8, but there will be a remainder of 1, right? 8 divided by 2, that is 4, there will be a remainder of 0, right? 4 divided by 2, that's 2, and there will be a remainder of 0. 2 divided by 2, that is 1, and there will be a remainder of 0. 2 divided by 1 divided by 2, that is 0, right? Once you get the 0, the remainder is just whatever is on top, you bring it down, right? So let's go from bottom to top. Let's go. So that will be 1 0 0 0 1 1 in base 2, right? So let's see. 1 0 0 0 1 1 in base 2, and that's option C. Great. So let's see. Let's look at the next question. So it says, in what number base is this addition, right? Now, when I saw this question, the first thing that will come to my mind, I might not even be interested in the options, right? But if I look at the last number, this is 5, this is 4, this is 5, right? So regardless of the base I'm working with, 5 plus 4 is 9. 9 plus 5 is 14, right? That means for me to have 0 here, based on the way we've been doing it, right, is either the number is actually in a base. So if it was base 14, I'll have said 14 divided by 14, right? That'll be 1 remainder 0, and drop the 0, right? I'll drop the 0 and carry over the 1, right? But in this case here, so it could be 14. That's a possible answer. What other? It could be 7, right? It could be 7. because we have 14. 14 divided by 7 is 2, remainder 0, right? 2 remainder 0. So I will have dropped the 0 and carried over the 1. That means that 7 and 14 actually align, because the last number here is 0. So it must either be 7 or 14. Right? So let's look at the options. So we have 10, 9, 8, 7. So without even solving this, right, I already know my answer is 7, just because I looked at the last number and I did my extrapolation. So instead of me solving and trying, oh, is with 10 work, will 9 work, no. Just look at the last number and try it. So if I had done 10, 5 plus 4 plus 5, that would be 14. 14 divided by 10, right, that would be 1 remainder 4. That means this last number will have been 4, but that's not the case. Same thing as every other thing, only 7, right, marks this box. And if you see, the answer is what? Is D, right? So I also want you to try it by yourself. Try and add this 3. We've done addition before, so try and add this 3 in base 7 and confirm if you're going to get 1050, right? But that's the solution to this number 10. So let's go to the next question. The question says, if 23 base x is equal to 32 base 5, find the value of x. This is taken from 2014 WAEC question. Right, so 23 base x and 32 base, these are different bases, right? So before we can compare both of them, they first have to be in the same base, and then they have to be the same base. They have to be in the fundamental base, right? Fundamental base is our base 10. So I have to convert this one to base 10, convert this one to base 10. I advise that you pause the video and then you try it out yourself. Welcome back. So let's see. So the question says that if 23 base x is equal to 32 base 5. So let's convert it to base 10. So this is to base 10, right? As always, this will be 2 times x plus 3 times x, right? And from right to left, you give it the power starting from 0, right? And then let's convert this one to, so it will be 3 times 5 plus 2 times 5, right? Give it the power from right to left, 0, 1, right? So 2 times x1 is actually 2x basically, plus 3 times x anything raised to power 0, regardless of whether it's x or y or 3 or anything raised to power 0 is 1. So 3 times 1 is 3, right? So 3 times 5 raised to power 1 is 5, so that will be 15, plus 2 times 5 raised to power 0, this is 1, so 2 times 1, right? So 2x plus 3 is equal to 17, right? So 2x is equal to 17 minus 3, which in this case is 14. So 2x is equal to 14. So if I divide both sides by 2, right, I'll find the value of x. So if I divide this by 2 and then divide this by 2, so my x is definitely equals to 7. Great. Let's see if we got the answer. So these are the options. So our answer should be option A. Great. And then we got it right. So let's call ourselves very good, right? So that's it about it. And if you got it, well done to you. So let's go to the next number, number 12. Number 12 is saying basically still the same thing, right? I want you to pause this video and try it out yourself. Welcome back. So if just basically in the same line, so if 124 base n is equal to 232 base 5, right, find n. So we want to find n. So we have to convert this to base 10 and convert it to base 10. Still the same line of thoughts. Right, so that will be 1 times n plus 2 times n plus 4 times n. So from right to left, give the power. So this 0, this 1, and this 2 is equal to the same thing. So that will be 2 times 5 plus 3 times 5 plus 2 times 5. So 0, 1, 2, right? So 1 times n squared is n squared, plus 2 times n raised to power 1, that will be 2n, plus 4 times, this is 1, so 4 times 1, that will be 4, is equal to 2 times 5 squared. 5 squared is 25, so times 2. That will give me 50. Plus 3 times 5 raised to the power 1 is 5 raised to the power 1. So 3 times 5 is 15. Plus 5 raised to the power 0 is 1. So 2 times 1 is 2. Right? So this is n squared plus 2n plus, so having a quadratic equation, is equal to 50 plus 15 is 65 plus 2. That is 67. Abi? So let's carry over this 7 to this other side. And that will be n squared plus 2n plus 4 minus 67 is equal to 0. Right? So let's simplify. N squared plus 2n plus 4 minus 67, right? If you press the calculator, that will give you minus 63 is equal to 0. So the way we do quadratic equation, we join the first and the last together. So this is plus n squared and this is minus 63. So by the time we multiply the number together, that will give us minus 63 n squared, right? So we'll look for two numbers that when we add them, they will give us this middle one, the one that we did not touch, which is this middle one, and then we multiply them, they'll give us minus 63 n squared, right? So what are the two numbers that we can do? So if you don't know the two numbers, you can use the long division method, right? And say 63, right? So the first that can divide this is 3. 3 in 63 is 21, right? 3 in 21 is 7, Abi? And then you divide by 7, so this give you 1, right? So what two numbers can we be able to decipher from this, that when we add them to give us this, and when we subtract it to give us? So if I join these two, this 3 and this 3, so 3 times 3, so the numbers are 3 times 3 times 7, Abi? This is the breakdown of 63, right, in terms of prime numbers. So if I join these two, which is 3 times 3, let me make it more clear. 3 times 3 is 9, so 9 times 7, right? So look at this. If I say 9 times 7, right, that will give me plus 63, but I need minus 63, right? And I also need plus 2n. So if I say 9n and minus 7n, would this work? Let's see. 9 times 7 is 63, n times n is n squared, minus times plus is minus. Great. 9n minus 7n, right, that will give us 2n. So this is very perfect, right? So the two numbers that we're going to replace this n 2n will be 9n and minus 7n. If any of this is looking very strange, we'll still treat quadratic equations going forward, so that is fine, right? So let's replace. The next is that when we find these two values, we replace the middle with those two values. So that will be n squared plus 9n minus 7n minus 63 is equal to 0. So the next thing we're going to do is you group these first two. What is common in these first two? I can see n here, I can see n here, so I can factor that n, right? So n squared divided by n, that will give me n, plus 9n divided by n, that will give me 9, right? What is common in both of them? I can see minus and I can see 7. If I divide 63 by 7, I will have the same answer. So that means minus what? 7. I can factor minus 7 from this. Minus 7n divided by minus 7, that will give me n. Minus 63 divided by minus 7, that will give me plus 9 is equal to 0. Like I said, if anything is looking very strange here, it's understandable. When we treat quadratic equations, you can come back to this video and see that there is nothing to it. So in quadratic equation, the next thing that we do is that since you must have the same value inside the brackets, right? So we have n plus 9, we are good, right? So we'll now take this value, the values that we factored out, we'll put them together. That will be n minus 7, we'll put them together. I'll take one of the two brackets, which is n plus 9 is equal to 0. So if I take this first one, n minus 7 is equal to 0, or n plus 9 is equal to 0. If I make n sub the formula here, this one will come over here, that will be n will be equal to what? 7, or n will be equal to what? Minus 9. So let's look at the question and see the reasonability. Can you have a base that is a negative number? No, you can't. You can't have a base that's a negative number. So that means that this one is out of the equation, right? That means our n is equal to what? 7, right? So let's see. Our n is equal to 7. This was a theory question in 2014, right? So they expected that you should have known quadratic equations, and if you don't know it, once again, it's very fine. We'll still review it in the future videos. So that is that about that question. Let's see this question. It says, what is the sum of 11011 base 2, 111 base 2, and this guy base 2 is this? Then I says find the value of m and n. So we just need to add these three and then compare and find the missing values of m and n. Right? Let's solve that. Again, you might want to also pause the video and actually try it, because we've done additions similar to this before. Wait, so let's go. So this 11011 in base 2. I'll take the first two first, plus 11111 in base 2. Great, let me solve this two first. 1 plus 1 is 2. That is equal to the base that we're in. So I'll say 2 divided by 2. That is 1 remainder 0. Like always, we drop the remainder and carry over the results, right? So 1 plus 1 plus 1, that is 3. 3 is greater than 2. So I have to divide again. So that will be 1 remainder what? Remainder 1. Great. So I'll drop the remainder and carry over the 1. So 1 plus 0 is 1 plus 1, that's 2. So this one will kick in. So I'll drop the 0 and carry over the 1. 1 plus 1 plus 1, that's 3. This will kick in. So I'll drop the 1 and carry over the 1. 1 plus 1 plus 1, this will kick in. That's 3 divided by 2, 1. So I'll drop the 1 and carry over 1. This is our imaginary 1. We'll just bring it down, right? So I've done this first two addition. Let's do the last addition there. So plus 1 2 3 4 1 2 3 4 1, right? Great. So still in base 2 and still in base 2. 0 plus 0 is 0, right? 1 plus 0 is 1. This is 0. 1 plus 0 is 1. 1 plus 1 is 2. 2 divided by 2. Because 2 is now the same base, I have to use this, right? So I will drop 0 and carry over 1, right? So 1 plus 1 is 2. I'll drop 0, right? Still the same thing. Drop 0 and carry over 1, right? So when I add those three values, this is what I have. Now let's compare to what they add. They're looking for 10m, 10n0. So let's just compare. By comparison, we know that m will be equal to what? 0, and n will be equal to what? 1. Very good. So the most important thing we wanted us to test here is, do we know how to add in different bases? That was what they were telling us to do. And like I said, even the same base is just adding normally, right? So you can go and visit our video on addition, right? So let's see. So we said m is equal to 0, n is equal to 1, right? That is like option C. So let's see what the answer is. Great. Our answer is option C. We're doing very great. Well done, everyone. Now let's go to the next question. This question is saying that if 23 base x plus 101 base x is equal to 130 base x, find the value of x. Now look at this. So before I even do this, so the last value here is 0, right? So let's see. The last value here is 3. Last value here is 1. 3 plus 1 is 4, right? So that means that whatever I have, whatever my value of x is, right, it must be something that if I divide 4 by that number, I'm going to get the remainder of 0, right? So what it is that I can divide 4 by that will give me a remainder of 0, right? So that, that will be like 2 and 4, right? So our value of x should be either base 2 or base 4. And without putting pen to paper, I know that my answer is what? Is D, right? So whenever I see things like this, I see the last value is 0, just add the last two values 4, right? You know that whatever you're going to be having as the base must be something that must be divisible by that 4, and will give you a remainder of what? 0, because that remainder we are dropping here, and that makes sense. And I've solved that, and I move away to the next question. Magic, right? Don't worry, you see that. So look at this now. So we have two different bases, right? So you might want to pause the video and actually try this out. So we have 23 base y is equal to 111 base 2, right? Because they're in different bases, we have to convert them to what? To base 10, right? So let me move this. Let's move this up. So we have 23 base y is equal to 1111 base 2. So let me convert this to base 10. So this will be 2 times y plus 3 times y, right? And give it the power of 0 from right to left. So this will be 1 times 2 plus 1 times 2 plus 1 times 2 plus 1 times 2. Give it the power from 0 from right to left. Right. So 2 times y raised to power 1, that will be 2y. Plus 3 times y raised to power 0, y raised to power 0 is 1, so that will be plus 3. 1 times 2 raised to power 3, that is 8. Plus 1 times 2 raised to power 2, that is 4. Plus 1 times 2 raised to power 1, that is 2. Plus 1 times 2 raised to power 0, that is 1. Right? Great. So that would be 2y plus 3 is equal to 1 times 8 is 8. Plus 1 times 4 is 4. Plus 1 times 2 is 2. Plus 1 times 1 is 1. Right? So let's simplify. So this will be 2y plus 3 is equal to 8 plus 4, that's 12. Plus 2, that's what? 14. Plus 1, that is what? 15. Right? So let's correct like terms by taking this plus 3 to the other side. So that will be 2y is equal to 15 minus 3. Right? That will be 2y is equal to 15 minus 3 is what? Is 12. Right? So if I divide both sides by 2, I'll be able to find my value of y. Right? So y is equal to what? Y is equal to 6. And this is our answer. Let's see if what we do is correct. So by default, our value should be C. Great, our answer is C. Right, so if I'm moving too fast, you can always slow down the video, right? But that's it. So convert both of them to base 10 and then find the value of y. So that's from 2019. So let's go. Right, look at this question too. So it says it's almost similar to the same thing that we've done, right? So you might want to actually try this by yourself. Welcome back, right? So let's see this one. Let's look at it together. So if 110x is equal to what? 40 base 5. Of course, it's telling that I should find x. So let's go. Convert both of them to base 10. So that will be 1 times x plus 1 times x plus 0 times x. So give it the power from right to left, starting from 0. So this is 0, this 1, and this 2, right? Is equal to, let's convert this to base 10. So 4 times 5 raised to plus 0 times 5, right? So give it the power of 0 from right to left. So this will be 0 and this will be 1. 1 times x squared is x squared. Plus 1 times x is x. Plus 0 times anything that is 0 will give you 0. So I don't need to bother myself. Is equal to 4 times 5 raised to power 1, that's 20, right? Then this is 0, so I don't need to bother myself with this. So let me carry this 20 to the other side. That will be x squared plus x minus 20. And the way we did it before, right? Quadratic equation, right? So this is going to be equal to 0, right? I joined these last two together to get minus 20x squared. What are those that if I multiply will give me 20? And if I minus give me x, of course, that should come to you. So 5x and 4x, right? So you just need to know where we put the minus. So you can see the value of x is positive. So I'll put the minus with the smaller one, right? Right, so that 5x minus 4x will give me x, right? I mean, I have 5 of something and I'm subtracting 4 of that thing. So I'm going to only be left with 1 of that thing, which is something as x, right? So if I replace this x with 5x and minus 4, right? So that'll be x squared plus 5x minus 4x, then minus 20 is equal to 0, right? Then the next thing, like I said, I will do quadratic equation. We'll factor out this first. So factor out what is common. What's common both of them is x, right? So x divided by x is x, plus 5x divided by x is 5. Right, so what is common in these two? I can see minus is common in both of them, and I can see 4 is common in both of them. So I'll factor out minus 4, right? Minus 4x divided by minus 4, that will give me x. Minus 20 divided by minus 4, that will give me what? Plus 5, right? Because 20 divided by 4 is 5. Minus divided by minus is plus. So I'll group what I factored out together. That will be x minus 4, and take out one of the brackets, right? So that will be x plus 5. Just like we did in the previous example, is equal to 0, right? So now I will now do each of them and equate to 0. So that x minus 4 is equal to 0, and then x plus 5 is equal to 0. If I take this to the other side, that will be x is equal to 4, or x is equal to what? What would this be? Equal to minus 5. You're correct, right? So because X cannot be negative, right? There's no negative base. Therefore, our X is equal to what? Is equal to 4, right? And that's correct. Let's see if you're correct. Great, our X is equal to 4. Once again, this is a theory question that came out in 2019. So we are good to go, right? Great. Let's look at the next question. This is taken from 2020. So if 101 base 2 plus 12 base y is equal to 23 base 5, find the value of y. Right? Already we know that when we have different bases like this, we are going to convert each of them to base 10. So let's go. (101) base 2 plus what? 12 base y is equal to 23 base 5. So I have to convert each of them to base 10. Right? So let's see. That will be 1 times 2. Let me do this in brackets. Plus 0 times 2 plus 1 times 2. Abi? 1 times 2, 0 times 2, 1 times 2. So I'll give it the power of 0 from right to left, plus 12 base y. That will be 1 times y plus 2 times y. Right? Give the power of 0 from right to left is equal to 2 times 5 plus 3 times 5. I'll give the power of 0 from right to left. So let's expand the brackets. 1 times 2 squared. 2 squared is 4, so 1 times 4 is 4. Plus, this is giving me 0, so I need to bother myself with it. 2 raised to the power 0 is 1, so 1 times 1 is 1, right? Plus, 1 times 0 raised to the power 1, that is y. Plus 2 times 0 raised to the power 0, y raised to the power 0 is 1, so 2 times 1 is 2. Is equal to 2 times 5 is 10. Plus 5 raised to the power 0 is 1, so 3 times 1 is 3. Let's simplify. 4 plus 1 is 5. 5 plus 2 is 7. So that will be y plus 7. Abi? Great. Is equal to 10 plus 3. 10 plus 3 is what? 13. So y is equal to, let's call it like terms. Carry this one to the other side. That will be 13 minus 7. Right? So what is our y equal to? When you do 13 minus 7, your y will be equal to what? It will be equal to 6. Let's see if what we did is correct. So that will be option what? Option C. And we got it correctly. Well done, everyone. If you got it, well done. Let's see this next question. The next question is taken from the most recent WAEC, right? This is the month of June 2022. So this one came out in the WAEC that they wrote this particular year. So it says change 432 in base 5 to a number in base 3, right? So I want you to actually pause the video and try it out yourself. Welcome back, right? So whenever we're given this type of thing, the first thing I always do is convert this base, right, to base 10. Then from base 10 we'll convert it to base 3. So let's go. So we have 432 base 5, right? I want to convert it to base what? Base 3, right? So let's go. First, convert it to base 10. That's the first thing, right? So that will be 4 times 5 plus 3 times 5 plus 2 times 5. Give it the power of 0 from right to left. So that will be 4 times 5 squared is 25 plus 3 times 5 raised to the power 1 is 5 plus 2 times 5 raised to the power 0 is 1. So that will be 2 times 1, right? 4 times 25 is 100 plus 3 times 5 is 15 plus 2 times 1 is 2. So by the time I add all of this together, 100 plus 15 is 115. 115 plus 2 is 117. Abi? Great. So we have it in base 10. Right, so the only next thing for us to do is to convert this base 10 to what? To base 3. So 117 base 3. So 11 divided by 3 is going to give me 3 with the remainder of 2, right? So 3 in 27 is 9. So that means that there's no remainder, 0. 3 divided by 39, of course, 3 in 3 is 1. 3 in 9 is 3. So remainder 0. 3 in 13 is going to be 4 because 3 times 4 is 12, right? But the remainder of 1. 3 in 4 is going to be 1 with a remainder of 1. 1 divided by 3 is 0, right, with a remainder of, when you get the 0, just bring down the remainder here, which is 1. So from bottom to top, right, that will give me 1, 1, 1, 0, 0 in base 3. Right, so let's look at the option. So 1, 1, 1, 0, 0 in base 3. Right, so that means our answer is option B. Right, our answer is B. Great. And with this, we've actually covered all questions from 2004 to 2022 that came out on number basis. It's always easy to build on the fundamental, right? That's why we have to spend so much time, right, talking on the fundamental. You never know which one will come out in your school exam or your WAEC, right? So it's always good to have a well-rounded opinion, right, or a well-rounded knowledge on all of the different subsets of the number base, right? And with this, we've come to the end of this particular video. If you found it interesting, please like the video and subscribe to our channel so that you can be up to date with all of the amazing content that will be churning out. And if you have any question, or if you have any contribution or any suggestion or anything at all that you want to share with us, right, please comment in the comment section for this video. See you guys in the next video.